everyone. Thank you for joining this session. My name is Pradeep Donepudi, and today we are going to explore a topic that's become critical for every data driven organization, the synthetic and masked test data for compliance. Okay, over the next few minutes, we will discuss how the landscape of test data has shifted from development afterthought to a major compliance risk. Okay, we will dive into the innovative tools and strategies, particularly data masking and AI powered synthetic data that are helping organizations navigate this new reality. Okay, by the end, you will have a clear framework for how to protect your non production environments, accelerate innovation, and also maintain compliance. Let's get into it. Okay, let's start by addressing a dangerous myth that many organizations still operate under. Okay, so the idea that test data is somehow safe or exempt from strict regulations that govern production data. The reality is that non-production environments, especially your dev or test or QA systems, have become the new epicenter for compliance risk. So this isn't just a theoretical threat. We have seen major breaches originate from these lower environments. For instance, a major financial services firm you might have recently heard about, like, was hit with $80 million fine after a hacker accessed 100 million customer records from a misconfigured development environment. So this proves the stakes are incredibly high. Okay, so this risk is basically driven by a perfect storm of three converging factors. First, the expanding regulations. Basically, we never heard of CCPA, 10 years back, not GDPR 10 years back. So this laws like GDPR or CCPA and HIPAA, uh, those are coming in and they no longer differentiate between environments. If the sensitive data is present, the full force of the law applies. The penalties, like something like GDPR, would also penalize, which reaches up to 4% of global turnover. Okay, and the second is the pace at which we are going, right? The development velocity. Like, modern CI/CD pipelines are fantastic for innovation, but they also create countless copies of data, unintentionally, like, expanding the attack surface, right? And creating more potential points of failure. And the third one is organization silos. Security teams have traditionally focused on hardening production, while development teams are focused on speed. The the challenge is, like, who would take care of test data, right? So there's a vacuum that is left out in that space, without no full responsibility taken for test data compliance. Okay, so this isn't a opinion or something that we are stating, but however these are defined by, codified by industry standards. For example, this CSA, which is a Cloud Security Alliance, for example, is explicitly stating that, um, that production data should not be used in non-production environments. So the message is clear: the old way of handling test data is no longer acceptable. Okay, so how do we address this challenge? The industry has developed two core technological solutions so far. One is data masking, and the other one is synthetic data generation. We'll go through both of these processes and understand, which is better, where should we use what, and so on, right? So I'll just walk you through what is data masking. Data masking is a process of transformation. It starts with the copy of your real production data and alters sensitive fields to protect them. while keeping the data structures and also the formats intact. There are different masking techniques. Let's discuss a little bit more about most commonly used data masking techniques. First one is dynamic data masking. As you know, dynamic meaning sometimes the sensitive information is shown, sometimes it's not shown, especially depending on the privileges that the user has, whoever is accessing has. For example, like if you are taking an example of a call center, where an agent can see the credit card numbers marked out XXX, except for the last four digits. But however, if the call is transferred towards a manager, who would be able to view the entire number. Okay, so it's very specific to roles, the user roles. So, and that's how they do the masking. Um, the another one is another powerful technique is tokenization, which you see every day, if like some services like Apple Pay, Google Pay, like where the actual credit card number is not used. Instead, there is a new number that is completely irrelevant to the original number is generated, and then it is it is used for any transactions. Even if the breach occurs, the token is useless for an attacker. So there are other methods as well, like subsetting, shuffling, and also encryption. So there are some few of these techniques will be used during data masking, especially for masking sensitive content while moving out of production to any lower environment. On the other hand, the coming to synthetic data, it's a process of data creation. It uses most of the new ones uses like AI models to generate entirely new artificial data that statistically mirrors your real data. Okay, the key advantage here is privacy, basically, because data contains zero real personal identifiable information. The risk of re-identification is virtually eliminated because everything is made up content, but however it looks realistic. So even if the data um, is in the wrong hands, could not be used or would be of no use for them. Okay, so there are multiple techniques here as well, how data can be generated. Some of them are rule based and statistical data. Um, this is basically when you define the rules on how the data should be generated based on those rules, and also the statistical spread based on the statistical spread of what you want to generate. For example, you wanted to generate customers based out of certain state, within certain zip code, and then you wanted that to be 10% of the total population in the state. So some of these rules can be clubbed together, and then um, they define data based on those rules, and then the statistical information that is most widely used approach. And the other one is data augmentation, where you'll be using existing data to fill the gaps and enhance as per the needs, and enhance the data, basically the existing data, but you enhance it based on what is required. So the third one is AI generated one, which is using more advanced models like GANs and VAEs. We'll go through in detail in the next slides, but however they are used to generate data in different formats based on the pattern learned from the original from the source data sources. When it comes to test data generation, it's always been whether we should use data masking versus whether we should use synthetic data. So I'm here to tell you that that mindset is obsolete. the most effective modern strategies don't choose one over the other. They use both as complementary tools in a unified toolkit. Okay, Gartner's latest market guide for data masking explicitly recommends that organizations prioritize tools that offer both masking and synthetic data generation to enhance security and accelerate development. Okay, so now it is everywhere, like that we'll have to start embracing that fact that it's not just one or the other, but it's both. Okay, a helpful way to think about this is as a data portfolio. Think of mass data as your blue chip asset. Okay, it's stable, it's reliable, perfect for testing complex legacy systems where preserving existing relationships is critical. Now think of synthetic data as your growth asset. Okay, it fuels innovation, enables AI development, and allows you to test new features where real data does not even exist yet. Okay, so however, architecting the right solution isn't simple. It involves navigating, complex trade-offs between data realism, privacy guarantees, and cost. However, architecting the you need some helping hand, like to get the right solution. So engaging some TDM experts will become invaluable. Okay, they can help you design a strategy that aligns with your specific compliance needs, risk appetites, and also development goals, ensuring the right balance is met. Okay, in the next few slides, I will talk about few sample use cases on what approach to use when. Okay, so the most significant innovation in this space is the infusion of AI across the entire test data lifecycle. AI is no longer, just a tool for generating data. It's the engine that automates, elevates every step of the process. Okay, it starts with AI-powered discovery. Old methods of finding sensitive data relied on brittle scripts and manual reviews. Today, AI uses machine learning and natural language processing to scan entire data landscape with contextual intelligence. For example, some of the telecom providers today, they use AI to improve accuracy, to classify their network data by over 26%. So any of the tools that you see today, like either big data or the market leaders like Colibra, so you'll be able to see most of them use some of these AI features to scan through volumes of data and then classify um, quickly, on for your whole enterprise. So test data will be tapping on some of these AI powered discovery methods, to make sure that whatever we are masking or whatever we are trying to generate is in sync with what is existing today. So next is the AI powered generation and masking. Okay, this is where generative models like GANs and then LLMs create hyper realistic synthetic data. So AI can also intelligently recommend the best mapping masking technique, for a given type data type, ensuring optimal balance of privacy and utility. So finally, AI drives provisioning and orchestration by integrating with CI/CD pipelines. AI enables also the on-demand provisioning, for compliant test data directly, into automated workflows. So this whole, whole concept is governed by policy as a code, where data protection rules are defined and managed just like application code, embedding auditable governance directly into your development process. So the other concept is the prompt as a code, like um, which eases out the process of obtaining test data by removing the complexity um, uh, that is underlying. I mean, user does not really need to know what are the data structures, how these are aligned, how what is the integrity between them. All this complexity is removed with just prompt as a code, um, where user should be able to just say, like, certain state, certain age, and then these are the customers that I need, these many customers I need, and then the data is either generated or pulled from the existing content. So it is made so much easier and better with this AI infusion. Okay, let's talk a little more about the AI models. I've been mentioning about GANs and also VAEs. Okay, so specifically these two, why we have chosen is, like, you can think GANs, which is generative adversarial networks. You can think this as a competition between AIs, right? A generator that creates fake data, and then a discriminator that tries to spot the fake. So when it hits a balance, like, this is like an adversarial process, which forces the generator to become incredibly good at creating realistic data. So um, for example, there are many industries that use GNs today, like, for example, in finance, like, there are specific GNS, like, um, GNs, like, which are used to generate synthetic stock price data. Okay, while the usage is also there in healthcare, like, where they create synthetic medical images, to train diagnostic AI. Okay, and coming to the next one, which is variational autoencoders, VAEs, which these models work by compressing the real data into its essential features, and then using that compact representation to generate new similar data. They are widely used in, like, let's say, primary industry that we see is in manufacturing, like, where for they use this for primarily for anomaly detection. Uh, and also we see that, like, in healthcare, to augment training data sets for medical imaging. And finally, the newest waves includes, like, just like how we spoke about, like, the LLMs are now, how user can be would be able to just provide a prompt, and then would be able to fetch data either by creating or by uh, just by masking and then searching the existing content. So we are all familiar with models like GPT. They have revolutionized, like, the text generation, and can be, like, now be prompted to create realistic structured data. So a great example, I would say, like, is using LLM to generate thousands of fake customers, like, for customer support chat logs. Okay, to train a new service bot without using any real customer conversations. So these are few things, that are widely used today. Okay, moving on to the next one. Uh, the whole thing, like, brings us to a critical point, which is uh, safe data, but also be useful data, right? So it's not just safe data that we need, but also that should be usable. Okay, so a perfectly private data does not make any sense, like, like, if it misleads your AI, right? Like, the model is completely a failure. So therefore, a robust validation framework is essential, and the whole thing rests on three pillars. I would say, like, one is business logic and logic integrity. So your test data must adhere to real world business rules. A common failure is generating a test data where uh, let's say where an invoice date comes after the payment date. Okay, so this will cause the test to fail for the wrong reasons, wasting all the time that you have spent on creating those that content. Okay, now second one is privacy validation. So we need to confirm that our protection measures worked. Okay, so this involves using metrics to measure the probability of re-identification. In one study, like on synthetic patient data, like researchers were able to prove a re-identification probability of just 0.008 percentage, so which is pretty low. Okay, and third one is statistical and also utility validation. um, so the synthetic data or mass data must accurately reflect the statistical properties of the original ones, right? A powerful technique like here is train test evaluation, like I would say, like where you train one AI model on synthetic data and another one on real data, then compare their performance. A small performance gap indicates high utility. So that's how, like these are these work together. So manually checking, like these pillars across millions of records will become impossible, sometimes impossible. So this is where automated data validation tools become essential. So they can programmatically run these checks, providing continuous assurance that your test data is not only safe but also it truly fits the purpose. Okay, so moving on to the next one. So as I've mentioned earlier, like I would like go through high level use cases and then what kind of data is used in each one of these. So let's discuss about these common use cases and what solution would be the right fit for each use case. If you are talking about a new product development, when developing new products or features, you often face like a chicken and egg problem, right? So you need data to build and test, but real user data does not exist yet, right? So synthetic data is a clear solution here. It allows your teams to start building, testing, and also iterating from day one, uh, completely eliminating the bottleneck of waiting for real world data to become available, right? So that is one big advantage. So usually, in development, whenever you have development activity, synthetic data is the one that go to solution. So there might be some instances where you'll have AI and ML model training, right? So in these cases, like AI generated synthetic data is transformative, like for training machine learning models. Okay, real world data is often incomplete and lacks the rare, dangerous or unusual edge cases, right? That a model must learn to handle. So with synthetic data, you can specifically create data for these critical scenarios that are too difficult or unsafe to capture in reality. So this directly improves the model's accuracy and robustness, and also system is all prepared, for any kind of activity that happens in future. Okay, so that's the benefit, like and using AI and ML model training. Okay, coming to the third one, legacy system and QA testing. So as we spoke about earlier as well, like when you are testing legacy systems, where data integrity is important, at the same time, like your solution, your data sources are robust. That's where, like you rely mostly not on developing a new solution altogether, but to tap on the existing framework that you already have. So testing existing legacy systems, like presents a massive security risk. If you use real or sensitive information in non-production environment. So the primary solution here is data masking. Okay, so which scrambles or anonymizes existing sensitive content, right? So however, the mass data may not cover all necessary test scenarios, but by augmenting your mass data with synthetic data, you can achieve full test coverage, ensuring quality assurance across all possible cases, not just the ones that are present in your production database. So it's this is here you're heavily dependent on existing content, but however you are also filling the gaps by data augmentation, like with synthetic data. Okay, and the coming to the fourth one, which is like a sales demo or user trainings, like this is mostly every organizations involves in, like where uh, so when you need to collaborate with third party vendors or give sales demos, or you cannot expose sensitive content, oh, or internal or like even customer data, right? So the ideal approach is to create a hybrid sandbox, right? This is a secure isolated environment filled with realistic synthetic data that mimics your production environment. Okay, it also allows vendors to build and demonstrate their solutions effectively, because you will be able to control what should be in these data sources. And also you'll be accelerating the innovation sales cycles without ever having a risk of breaching any of the sensitive information. Okay, so on a high level, that is, these are the use cases that we have, and how we will be which kind of solution or technique is recommended. Okay, coming to the grid here, like once you define, like what solution you need, like we have like a AI powered AI powered framework, like which kind of works in a factory model. Like once you define solution for one, you will slowly adopt and then pull in the rest of the data sources or different applications as well from your organization, and follow the same path. Okay, similar path. So all we talked about earlier, like are represented here, and then we just wanted to show you in a pictorial representation on how this works. Okay, so if the old model of just copying or masking production data is broken and slow, the new model, like um so would have the, I mean, isn't static or data source at all, like in it's an automated, like in data model factory. So the conceptual architecture is what we have put in here. The core problem with traditional governance is massive disconnect between teams. Like you have compliance teams writing policies in Word documents, and developers who are just supposed to know them, like and manually interpret them. They would not have the time, or they would not have the enough guidance to go through those. Like this, what happens with this is either it makes the whole process slow, or it makes it more error prone. Okay, and it becomes a complete bottleneck, like in a CI/CD process, and also development pipelines. So the factory model solves that issue. Okay, let's walk through the flow. Okay, starting from the left, like where with the inputs. This is no longer just a database, because the input can be a request from a developer, what we call as, we already we mentioned about it, which is a prompt as code. okay, which we will discuss next. Okay, it can be set to uh, business rules, like how data should be generated, what additional conditions do you have, you do not have any customers over 18 years, a few things like that, right? Could be you do business in only specific states. Okay, so those kind of conditions could be predefined in the business rules, and also what is considered sensitive, and then how, like let's say you have a range of numbers that you want to generate. Like for example, the IDs that you want to generate is in a specific range that goes into those rules, and these rules are all considered while generating the data or masking the data. So all these inputs are fed into the central engine. This is the brain of the operation, right? This is where powerful generative AI models like live, and your GANs or VAEs, LLMs, that have learned the statistical pattern of your real data, right? So it also contains all the traditional masking and transformation logic. But the most critical component, I would say the real game changer, is the layer of embedded policies, right? This is the policy as code, right? So we translate your complex governance rules, your, let's say, your HIPAA requirements, you have GDPR, so all those, like into like machine readable executable code. So these policies are part of the engine, like they are not a manual review step that happens after the data is created. Like this is embedded into it. Okay, this is what we mean by uh, governance by design. Okay, so the factory is architecturally incapable of producing a non-compliant output, right? I put it the other way, like so you'll not be producing any non-compliant information with these kind of guardrails in place. So this ensures your compliance is automated, consistent, and also auditable every single time. Okay, and finally the right side boxes that you see, um, you get your outputs there, like because the engine is intelligent and is policy driven, it can provision the exact data sets you need for a specific use case. This can be either fully synthetic, statistically accurate data to train your new agentic AI models. Okay, it could be intelligent augmentation to create that rare edge cases your QA teams that need, or it could be security masked referentially intact data for your legacy systems. So this all in all is a paradigm shift we are talking about, right? So as change agents, like we are no longer just managing static data, like we are building and managing models and policies that create uh, the data on demand. Okay, now I would be transparent, like as change agents in this space. Like we have learned that technology is often the easiest part. The real bottlenecks are people, processes, and perception. Right. So these are our learnings from the field. Okay. So the biggest and the first one and the biggest one hurdle is the production is greatest, right? Mindset. So this is a cultural addiction. Like we constantly hear, but production data is the only real way to test, right? So the change management is the single biggest bottleneck. This change management is the single biggest bottleneck. Um, so our learning in this basically is like you cannot fight this battle. Okay, so fight this battle on all the fronts at once, right? So don't try to boil the ocean. Instead, identify high impact business use case where production data is a known painful bottleneck, right? And maybe it's AML model testing, or maybe new product launch that's stuck. So we prove the value there first, and then that success becomes the lever for a wider change. So we talked about the factory model as well earlier, like where you want to start slow, test test those low hanging take those low hanging fruits, and then adopt the same to the other applications or other areas as well. So our learning here is to frame the ROI in clear business terms. Um, so not the technical ones, right? Like we had we had success with three specific buckets, like risk management. This is simple, like you show them like the $80 million fine, like which from a non-prod breach, and say that the strategy prevents that, the strategy prevents that, right? And the other one is speed to market. Basically, data provisioning is significantly faster because developers or QA teams, right, wouldn't be waiting weeks, for a mass production copy. And also AI enablement. So this is the most powerful one. You cannot build the agentic AI future you want on the old untrusted data you might have. So this unblocks it, right? So the final hurdle is an approach that we all, if we have an approach like that one size fits all, that's a misconception. Like teams try to replace their entire TDM strategy at once. Yeah, it fails because of multiple reasons. It's disruptive, and it just confirms everyone's biases, that the new way doesn't work, right? So our solution is to make it as a factory model. Like we work with our clients to build this capability for one portfolio, prove it, learn it, and then we build trust in the process itself. Then we expand to the next portfolio. This is how uh, we should be creating a lasting change. Okay, moving to the next one. From our experience, like what the this slide is a perfect example of what we mean by being a change agent, right? So this isn't a simple find and replace masking job. Like this is based on our direct experience with a major healthcare client. The challenge they face isn't just protecting PII. Their core business runs on like EDI, XML files, um, where notorious complex and HIPAA is in there. We are talking about files, like EDI 834, which is the benefit enrollment file. Like it's deeply nested. If someone working in that area would know about it. Structured file, it's a structure file that defines a member's entire healthcare plan, their dependents, and their coverages as well. And similarly, like EDI 835, like the claim, payment, and remittance advice. Um, so this file must maintain your perfect referential integrity with a corresponding claim file, which is 837. So detailing every single payment, adjustment, and denial as well. So in this environment, a single error in a subscriber ID, let's say, or a group number can invalidate the entire test, which ruins the whole week's worth of effort. Okay, and also our solution like wasn't just to mask it. That's an old playbook, right? So we taught our synthesis engine the fundamental business logic, and also the structural rules of these EDI transactions. The result is we can generate 100% synthetic HIPAA compliant 834 and 835 files on demand. The data is completely artificial, but it is referentially intact and also statistically identical to real patient population, right? So this unblocks the entire testing and development life cycle. Okay, so that is one strong use case that we have solved, and also we have one more where we have worked with a similar to this healthcare client. Like we had one of our financial clients show the client shows a major evaluation. Like the goal is no longer just save data for functional testing. The new frontier is creating realistic data for testing the AI models themselves, right? So we are currently guiding a major financial institution in their strategic shift. Okay, so they are moving away from legacy, like 100% masking based solution, and have set a goal to become synthetic first. We are helping them get there. Okay, so this shift unlocks critical use cases that were impossible before. For example, take anti-money laundering. So you cannot find emerging fraud patterns in your existing production data. So the criminals have already moved on, right? So instead we statistically generate new data, come on, or adversarial scenarios, right? And emerging money laundering typologies to test the robustness of their AML detection models. So it's the same for fraud detection as well. Okay, so we can create realistic real world business events like sudden coordinated spike in transactions, from a new area, new location, to see if their AI fraud models can actually catch it. Okay, so but here's the most exciting part, right? AI resilience testing. Um, so how do you know, like, your AI model is robust? So we intentionally inject bad data into the system. I would say biased or malformed data or contradictory data to see if the AI model breaks, like becomes unfair or gives nonsensical answer. So this is how you build trust and test for things that are not obvious, right? So these are the two major use cases that I would say, like, we have worked on and successfully implemented, masking as well as synthetic data generation depending on the use case, right? Yeah, thank you, that's all I have for today.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.